In this tutorial, I'm going to show you how you can extract crypto market data in Python using Coingecko API. Let's now first show you some examples how to use their API by going to your documentation page. And so under documentation, what they have available is a classic API page where you can use HTTP requests, and also you can use WebSockets for real-time data streaming. Before we can start using the API, we first need to get access to our API key. And so to get the API key, you can click on this link here and it will redirect you to their plans page. And if you want to try the product for free, Coingecko also offers a free demo trial where you can, create an API key using this demo dashboard. But if you want to retrieve live data for your live production applications, you can choose any of the packages that are suitable for you. Once you've chosen a plan, you can go to your developer's dashboard, and here you will find your API key, and we are going to use this key to access their API. So let's now copy this key and then put it as an environment variable inside our PyCharm IDE. So to add our API key as an environment variable in our Jupyter notebook, we can configure that by going to our configure Jupyter server. And here in environment variables, we can create a variable where we can store our API key. So I'm gonna call this Coingecko API key. And then I'm going to add the value of the API key that I've copied from the developer's dashboard. Now that we have saved the environment variable in our Jupyter notebook, we can test one of the API endpoints from Coingecko. So let's start with the ping endpoint. So if you look at this page here, you can then switch to Python and copy this code section here. So let's copy this and go back to our Jupyter notebook. So in this cell, we want to test the ping endpoint. And so if we copy the code here, we see that we have everything ready, but what we also need to provide is the API key in the headers. And this API key we have saved inside our environment variable. So what we also need is we need to import OS, and using OS, we will then save this API key inside a variable. So API key is equal to os.environ. And here we provide a key to our API key. So it's a Coingecko API key. So now after running this should have no errors. So now the API key is being saved in this variable. And now we run this cell, and we have to now just change this string here. So here we are providing API key. This should now return a response from the ping endpoint. And here Coingecko says V3 to the moon, which means that the API is now working. And this is great because now we can also test other endpoints as well. So now if you want to, for example, get a price of a coin, we can use the endpoint coin price by IDs. So again, you just have to, go to this endpoint, then you can again switch this to Python, you can copy the code and then go back to Jupyter notebook and put it in a cell and see what response you'll get. In this cell, we want to get the price by coin. And so here we are just again pasting the code block that we've copied. And as usual, we need to change this API key string to the one that we have saved in our Jupyter notebook. And so if we're gonna run this is not going to work because we still need one required parameter, which is the versus currency. So let's go back to our documentation page. As you can see, in query parameters, we are required to also provide VS_currencies. So we're going to provide that, and we're going to compare the price against the US dollar. In order to provide additional parameters, so here we can just provide the keyword params is equal to, and in this dictionary, we're going to provide the VS currencies. So we're going to provide the cryptocurrency price against the US dollar. And then what we can also do is we have to provide which symbols we want to compare it with, right? So we want to check, in this case, the Bitcoin price. So that's why I say symbols is BTC. So now by running this, we see that the current Bitcoin price is 91,506 USD. And so if you want to compare more than one cryptocurrency, right? So instead of just BTC, you can also provide a comma separated list of cryptocurrencies. So here I can, for example, say I also want Bitcoin and Ethereum. So here I separate both of them by comma. And if I run this again, I get the price for both cryptocurrencies here. Now let's say you want to analyze more than just Bitcoin or Ethereum. So if we go to this coins endpoint, you will find a list of coins using a coins list. And so using this endpoint, we will then get the full list of available coins on Coingecko. So now let's copy this and go back to our Jupyter notebook. So now you see that the process is very repetitive. So here we can get coins list. And here again, we copy the code block here. And as usual, we just here change this section and just add our API key. And now let's try to run this again. And as you can see here in this response, we have the list of our coins that are available at Coingecko. And for example, if you want to change this into a pandas data frame, so you have a nice tabular format. So what I can do is I can also import pandas as PD. And here, let's try to convert this into a pandas data frame. So I can call this data frame coin list df is equal to pandas.dataframe. And then here instead, of printing this, I will add this into this section here. And hopefully that will now print a nice data frame. So now you see that we have the list of coins here. And you see that there are many coins, right? So you can just go through all of them and see, what you want to do. And so this is just basically how you get all the available coins on Coingecko. Let's now have a look at the OHLC endpoint. So OHLC stands for Open, High, Low, Close, and it is basically the candlestick data for the cryptocurrency that you want to analyze. And this is important to compute historical data and technical indicators. And this endpoint just requires to provide the ID of the cryptocurrency. And so again, if we copy this code block here and put in a Jupyter notebook, let's see what we'll get as a response. So in this section here, we want to export the OHLC data. So here, let's paste what we've copied. And as usual, we want to here change this API key. And so let's say we again want to extract data from Bitcoin. So here, instead of ID, let's rewrite this to Bitcoin. And let's see what happens if we run this code block. And as you can see, we are still missing some required parameters. So here I have to provide params is equal to, and here versus currency, let's compare the Bitcoin price against USD. And what we also need is to provide the days. And this is basically the interval, for which we want to extract the OHLC data. And let's say we want to extract it for the past 30 days. So now let's run this. And as you can see, we now have a list of open, high, low, close prices. So let's now try to convert this output again into a pandas data frame. And the process is the same. So if you remember, we converted the coin lists into a data frame using this code here, and we can apply the same function to our OHLC df. So we can say OHLC df is equal to pandas diaphragm.fromDict, and here we convert this JSON response into a data frame. So now if we run this, now we see that we have the open, high, low, close prices in this tabular format here. And what we can also do is we can convert these columns or rename these columns so we know exactly what these values are. So we can, for example, use rename. And here we are going to rename the columns is equal to, and here the dictionary, we have to provide dictionary what we want it to rename to. So 0 in our case would be time. 1 would be open, then 2 would be high, number 3 would be low, and then number 4 would be close. So now let's try to run this again, and hopefully we have the data frame with the exact column names. Another thing you might ask is, why is this column a number, right? And this is just representing a Unix timestamp. And then to convert this to a datetime object, we can simply convert that by using this code line. So OHLC df time would be equal to, and let's write pandas.toDateTime. So pandas.toDateTime converts this Unix timestamp into datetime. And then we take this same column, and then the precision of this integer is most likely milliseconds. So if we then write unit is equal to ms and run this now you see that we've now converted this column into a datetime object. So now the last thing that I want to do is I want to visualize this open high low close price to show you the Bitcoin price on the chart. And for that, we can use Plotly. So here I'm going to import plotly.express as px. And then to create a line chart, I can say px.line. And here I will provide the data from my OHLC df. So here, this is my data frame. And on the x-axis, I will plot the time. And on the y-axis, I will plot the close price. So now let's run this and let's have a look at this chart. So here, what you can see is the Bitcoin chart for the past 30 days. And so maybe let's try to extract more data. So let's try to, have a look at Bitcoin price for the past 365 days. Right, so here I have exported Bitcoin for past 365 days, and here what you can see here is the Bitcoin chart for the past 365 days. And so yeah, so this is it for the video. Hopefully you liked it, and I will upload this Jupyter notebook on my website, so you will find the link in the description if you want to check it out yourself. And so thank you very much for watching, and I'll see you in the next video.